Hello everyone, welcome to the Digital System and Architecture Practical Series. So today we'll see how we can write a simple programs for data transfer operations with respect to microprocessor. So this particular practical will be based on 8085 instruction sets. So I'll just use these three instructions to write simple programs. The first instruction is move rd, rs. So this move instruction will of course move the data from one register to another register. So microprocessor, they have registers. In 8085 we have register A, B, C, D, H, L. These are the registers which are available to the user. So this instruction is a very simple instruction. This is a 1 byte instruction. Now what does this instruction do? This instruction transfers the data from one register to another. Like we have the instruction, one example is move A, B. So this instruction will copy the data from B to A. Okay, so source, so here RD means destination, RS means source. So RD can be any register, RS can be any register. In our case, this move A, B will transfer the data from register B to register A. The contents of B will be as it is and the contents of A will become equal to B. Then this instruction move D, C. This will transfer the data from register C to register D. So this is regarding the move instruction. Then we have MVI R, 8-bit data. So MVI means move immediate. Now R can be any register. This 8-bit data. So in 8085 we can transfer the 8-bit data to any of the register. So this is the 2-byte instruction. We'll see why it is called as 2-byte when we write the program. So this instruction, it stores the data, 8-bit data, in the specified register. Like suppose if we write MVI A, 15H. Now this H means it is a hexadecimal data, nothing else. Okay, this H means it is a hexadecimal data. So 15 data it stores in register A. MVI B 26H will store 26 in register B. So this is how MVI instruction works. Then finally HLT is halt. So this instruction halt, it halts the execution. Okay, when we want to stop the microprocessor from execution. So this halt instruction is written at the end of the program. So this is a 1-byte instruction. It stops the execution of the program. Now let us see some programs. Then first we will see the programs, then we will actually execute it on a simulator. So this is the first program. W means write a program to store 12H in register A, 13H in register B. Now whenever we want to write the 8085 program, we have to make 4 columns. The first one is the memory location, the second is the mnemonics, the third is the hex code, and we have the fourth is the comments. Now this program wants to store 12H in register A, 13H in register B. So the instruction to store 12H in register A is MVI A. Okay, this is the first instruction, MVI A. Now this MVI A is 2 bytes, so we leave one gap. Okay, so we are starting the memory location from 8000. So whenever we want to write the program for microprocessor, we need to specify the memory location. So this is the 8000 is the first memory location, then 8001, 2, 3, 4 and so on. So every memory location, it can store 1 byte of data. So because MVI is 2 byte, so 8000 we write this instruction and leave 1 byte 8001. Then at 8002 we write MVI B 13H. So this MVI again is a 2 byte because we have to store 13H in register B. So MVI B 13H and then halt. Now what is this hex code? Now hex code, we understand this mnemonics, but when we want to enter the code into the machine only understands the hex code. So for this purpose, MVI A, the hex code for MVI A is 3E. Okay, these hex codes are available. Okay, we can check the hex code. I will show in the simulator also how we can get the hex code. So MVI, the hex code for MVI A is 3E, then 12 will come afterwards. Then the hex code, we write MVI B, the hex code for MVI B is 06 and 13H will come afterwards, and HLT is 76. Okay, this will be generated automatically in the simulator. We don't need to worry, but I'll just return the hex code. We need to remember this. We need to know how to write this mnemonics. Okay, and even it will take the memory location by itself. So this is what we will write in the program. Then let us see the second program. This second program is write a program to store 91H in register C. E3 is also a valid data. As we know, in hexadecimal notation, we have from 0 to 9 alphabets and A to F. So E3 is another data we have to store in register D. So the first instruction is MVIC 91H. Then next instruction MVID after 1 byte, E3H, and it is HLD halt. Okay, so these are the hex code. Okay, even if you don't write E3H, it is okay, because this H, if you don't write, it is okay. So this is the second program. Now the third program is write a program to store 15H in register A, 17H in register B, and then transfer the contents of A to C and B to D. Okay, so first we have to store the data 15 in register A, 17 in register B, and then transfer the contents from A to C and B to D. So the first instruction is MVI, because we have to store 15H in register A, so MVI 15H, then 17H MVIB 17H. Now next we have to transfer the contents from A to C. So this is the instruction move C comma A. So this C comma A means what? Transfer the contents from A to C. That is what we have to do. We have to transfer the contents from A to C. Then next is from B to D. So move B comma, this is B comma D. Actually it should be D comma B. Okay, so this will transfer the contents. Okay, I've just made a mistake. Actually this should be D will come here. Okay, this is D and this is B. So that's the mistake. Okay, this should be D comma B. Okay, so this maybe the hex code may change. So this is move D comma B, not B comma D. It was my mistake. So this is the third program. Then the fourth one. Okay, this is the program. Write a program to store 18H in register A, 45H in register B, and interchange their contents. Okay, this is the interchange program. So we have to interchange the contents of, first we have to store the data and then interchange their contents. So first instruction is MVI A 18H, MVIB 45H. Okay, now see, when we want to interchange the data, we need to take a dummy register. So we take the register C. Okay, so what we do, we move the contents from A to C. Okay, so whatever data is in A, it goes into C. Okay, then move A comma B. So because of this, data from register B will move into A. So now B contains 45, so A becomes 45. Okay, now 18 was in register A, which we transferred in C. So now C contains 18. So last instruction is move B comma C, that is it will transfer the contents from C, which was actually the data of A. It will be transferred to B. So here we have to take a dummy register C. We cannot do A comma B comma A. It will just transfer one data itself into the other registers. So this is how we perform this practical. Now let us do it in a simulator. So this I am using the simulator Jubin 8085. I will show you how to download this simulator. Okay, now to get the simulator, it's a free simulator. Okay, you can, if you want, you can download any other simulator, but I am using this Jubin 8085 simulator. So this is the Jubin 8085 simulator. Okay, you can click on this Jubin Mehta's 8085 simulator. Okay, and then you will find a link. Okay, you can see that there are various links to. Okay, this practical can be performed either in board. Okay, on the board is also, this is the board. Okay, and the other way is also possible. Okay, so this is where, if you click here, download Jubin Mithras 8085. So if you click here, you will get a Java file. Now for running this particular software, this simulator, you need to install Java. If there is no Java, you can't run. So first install Java. If it is there, this will just run on a click. Okay, just click here, download the file. Okay, I have already downloaded the file. Okay, so you get that particular file, and then you can just run that particular simulator. Okay, if you click on that particular simulator, you will get this particular interface. Okay, this is what we are getting. This is the interface we will get. Okay, so check it. Now I'll show you how to use the simulator. Before using the simulator, we have to go to the settings. Okay, you can click on the settings, and this is set memory range. Okay, so by default the memory range start from 0000. I will just set it to 8000 because our program is starting from 8000. So I'll just set it to 8000. Okay, then we can just click on the registers here. Now this is the edit mode. Okay, so our program, if you check the program, what were the instructions? Let us see what were the instructions. Okay, so this is our first program. Write a program to store 12H in register A, 13H register B. So we'll just type this mnemonics MVI A 12H, MVI B 13H, and halt. So we'll just type this. Okay, so I'll just click here. So MVI, I can also use caps MVI A. Okay, sorry, I'll just take MVI A, MVI space A comma. Okay, is it 12H? Okay, so this is MVI A 12H. Okay, So this is MVI comma 12H. Okay, then MVI B, MVI space B. Okay, you can see the color is changing, 13H, and then HLT. So HLT. Now this, after doing this, what we have to do, you just type this code. Okay, then we have to assemble the code. I will show it how to assemble the code. So after writing the code, you can see at the bottom we have this assemble. Okay, I'll just click on assemble. When you click on assemble, we get this particular thing. Okay, so as we have written the program, this is the address. Okay, this is the address, this is the mnemonics, this is the hex code. These are the things we are concerned with. So okay, then so this will come. Okay, you can see the hex code is given 3E12H. as you can see in the program also, we have this 3E12H06 that is there. It will come automatically. So this is, we will get this. Now one more thing before executing the program, ensure that we have to start this. By default is 0000. We have to start from 8000 because our program starts from 8000. So this is 8000. Okay, now we can run in two modes, either step by step or run all at a time. I'll show step by step. So when we click on this step by step, okay, now it is ready. Forward, we will execute the first instruction. Okay, so this MVI A12, so you can see 12H is stored in register. This is, you can see the result accumulator means register A. So this accumulator means register A, it gets 12. Okay, then forward, sometimes we get this error. Okay, so this MVI B 13H, you can see 13H gets stored in register B. Then forward. Okay, so we are getting halt. Now the program stops execution. So this is how we execute the 8085 program using the Jubin simulator. This other programs, you can try out the other programs, all the other programs with this 2, 3 and 4. So after, in this particular program, after execution we get 91H in C and E3 in D, and with this program we will have this 15 will be stored in A and as well as C, and 17 in B as well as D. And the final one, although we start with register 18, so the data 18 will be stored in A, 4, 5 in B, but after execution these things will be reversed. So you can try it out. So that's all for this particular session. In case if you have any doubt, you can just type in the comment section. So thanks for watching.